Let us work on example 3. Example 3 is a little bit different than the previous. A universal set is defined as S equals 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now that was a lot of numbers. Sometimes we may want to write S is equal to X less than or equal to 11, 20, X is element of the integers. Really, and what this says is X is greater than 11, but less than 20, and X is an integer number. Exactly what we've said here. X is an integer between 11 and 20. O are odd whole numbers of set S. So I'm just going to put a dot right where all the odd whole numbers of S are 11, 13, 15, and 17. Now, P is all the prime numbers of S. So I'm just going to put some dots with the prime numbers of S, which include 11, 13, 17, and 19. We're going to draw a Venn diagram to represent S, O, and P. I have written S as the universal set, and that is that box. O is all the odd numbers in this set. So there is my set O. My set P is going to be this set right here. So I'm going to start putting in the numbers where I see fit. Now, I am going to start with the most specific, those that are both odd and prime. These include 11, 13, 17, and 19. Those numbers that are odd but not prime only include 15. Those numbers that are non-odd and not prime will include 12, 14, 16, 18, and 20. There's a Venn diagram to illustrate the situation. So now we are going to determine those numbers that are odd and prime. So here, these are the ones that are odd. And let's include those numbers that are also prime, which are no numbers at all. So what we get is those numbers that are odd or prime end up being 11, 13, 15, 17, and 19. So there we have it. Now I am going to determine the numbers that are odd and the complement of prime. So those numbers that are odd, so I'm going to do that right here. These are all the numbers that are odd. In the pink now, right? And this means not prime. So those that are odd but not prime, the only one that sticks out is 15. So the number of elements that are odd but not prime is 1.